In this video we're going to introduce the idea of entropy. Entropy is related to enthalpy and temperature by this concept called Gibbs free energy, which we will encounter later on. This is all part of our thermodynamics understanding. Okay, so we've got these two pictures here. We've got the soldiers placed on the left hand side in neat little rows here. Okay, whereas these soldiers are in a disordered fashion, falling off the side of a cliff. So here we've got, so on the left hand side we've got neat rows, no movement of the soldiers, whereas on the right hand side we've got this random movements and this disordered arrangements, and these are very important new terms, disordered and random. Okay. Entropy is the measure of disorder of particles. Okay. So another way to think about it is looking at this sandcastle. Okay. In the sandcastle there is a lot of order. There's billions of particles all arranged and in irregular patterns. So there's very little disorder. However, afterwards, after the sea's been at it, there is now more disorder, okay, because the particles are not ordered, or are less ordered, and as of consequence, the entropy is higher. Okay, certainly this is a favourite one of teachers. We like to think of it that we have our nice ordered bedrooms here. When you're an undergraduate, you're perhaps a little more messier, but certainly back in the teenage days, if we can remember back that far, it looks a bit more like this. So we can relate this idea to entropy by saying, okay, we've got high entropy as a teenager, medium entropy as an undergraduate, low entropy when you're employed. Okay, so now people who are in employment have ordered lives, and if you believe that. Okay, sorry, there is a short video that you can watch. If you type into Google Brian Cox and entropy, he does a nice little explanation as well. Okay, entropy is a measure of disorder in a system of particles. Okay, the more the disorder, the greater the entropy. The entropy of an individual substance always has a positive number because all systems have some disorder. All particles are in motion. It's only when you get down to absolute zero, minus 273 Kelvin, that there will be no entropy. But all particles that we are dealing with will have entropy, a positive entropy. Okay. So, looking at these numbers here, these substances, carbon is a solid, water is a liquid, oxygen is a gas. What can you infer from these numbers and these entropy values? Okay. Well, the main thing you can infer is, the main thing that you can infer is that there's a greater entropy going from a solid to a liquid, going from a liquid to a gas. Okay, and we're going to explain this on this next slide. It's because the particles are moving more, there is more disorder, and here, certainly in the gaseous state, we've got a random motion. You can plot entropy versus temperature on a graph, and this is a typical kind of graph that you may see in an exam question, where it shows that at temperature of 0 Kelvin you've got 0 entropy, but the entropy gradually increases for a substance until you get to a certain point where it rockets up vertically. The entropy increases as you're going from the solid to the liquid, so when you're melting, and then the liquid increases its entropy again gradually till you get to another point where the liquid becomes a gas, i.e. boiling point, and the entropy rockets, and then the entropy slowly increases again in the gaseous phase. Okay, and so the units of temperature are Kelvin because we've got 0 entropy. And again, linking this into the previous slides, the entropy increases because the particles are gaining energy, they are moving faster, and then they are spreading out more randomly. Again, we've just explained this point here. So at the melting temperature, the entropy increases greatly because there's much more disorder when the solids melt. At the boiling point, the entropy increases immensely, so a lot more. So the magnitude of the increase is much more than that of the increase when it's the melting temperature, and this is when the liquids evaporate. Okay. So final slide. Entropy increases as the temperature increases. The entropy increases greatly at a change of state. Gases have the most entropy. Okay. In the next video, we'll look at some calculations. Thank you for watching.